Hello students, welcome to this class of fluid mechanics. So in this class, now we are going to move step further in our study of fluid mechanics. So when we started our lectures, see, understand the flow, right? First we studied fluid statics, right? We studied fluid statics firstly. What we studied in that? We studied various properties of fluid first of all. That was the introduction to fluid mechanics, right? Then we studied about buoyancy and flotation concepts, metacentric height, what is metacenter. Then we studied about pressure and the various pressure measuring devices, right? Various manometers used to measure the pressure and all that, right? That we all studied in fluid statics. Then in next part we came to fluid kinematics, right? Fluid kinematics. In it, what we studied in this part, we studied about velocity, acceleration and momentum, right? This was the second part of fluid mechanics. Basically here we didn't study about the cause of motion of fluid. Here the change was in fluid statics, fluid was at rest. However, in fluid kinematics, fluid is in motion. But we didn't discuss that how the fluid is moving. What is the cause of that movement? There must be some force or torque, but we didn't study till now. So in fluid dynamics, third part is fluid dynamics. Okay, fluid dynamics. So here we will discuss about cause of motion. Discuss about cause of motion, right? Fluid statics, it was fluid at rest. Fluid kinematics, velocity, acceleration, momentum, or basically we studied about motion of fluid. In fluid dynamics we will study about the cause of motion. Okay, so basically what is fluid dynamics? It is the study of fluid forces, or we can say torque, right? Energy, power, etc. Fine, power, etc. Basically the study of fluid forces or the torque that is making the fluid move, or the energy or power that is required for the movement of that fluid, that we will all study in fluid dynamics. Okay, so from now on we will move towards fluid dynamics. The whole study ahead is on fluid dynamics. We will obviously use the concepts of fluid statics and fluid kinematics here also, but for the study of fluid dynamics. Okay, so first of all we need to know that what are the various forces that are acting on fluid whenever the fluid is flowing in pipeline or in whatever the case we are studying. What are the dominant forces that we must take into account, right? Okay, let's see. So first of all we will see about significant forces. Okay, significant forces. See, there can be many forces. Fine, you can say, okay sir, here is a electromagnetic force somehow, or there is electric potential also, but no, that are not dominating forces here. What we are focusing on, that are considerably affecting the flow of fluid. So what are those forces? First one is gravity force. Right? It is denoted by Fg. Gravity force is basically the force due to mass of fluid. Fine, like if you have to move the fluid to higher elevation, then you have to provide some extra power, right? However, if you have to send the fluid from greater height to lower height, it will move on its own, right? So that is because of gravity force. Second force is pressure force, right? The very important force, pressure force. It is denoted by Fp. Fine. Pressure force. It is because of pressure difference, right? If there is a pressure difference, the fluid will flow from high pressure to low pressure. Okay, we will study about that in detail ahead. So let's now just keep in mind that these are the significant forces. What is next force? It is viscous force. Viscous force. Okay, it will be denoted by Fv. Viscous force. What is viscous force? It is due to viscosity of fluid, right? If the fluid is not ideal, for ideal fluid we have considered that it is non-viscous fluid. However, that's not the case. That is only a hypothetical case. Every fluid must have some viscosity, maybe lesser, maybe more, but there will be some viscosity associated with every fluid. So if there is a viscosity, there will be a shear stress, right? Newton's law of viscosity we have studied. There will be a shear stress induced between the two layers. So because of that stress, there will be a resistance, there will be a force due to that viscosity. So that is called viscous force. So we need to take into account that force here. Okay, so in fluid flow, viscous force is also very important force. Next is turbulent force. Next is turbulent force. We will denote it by Ft. What I meant by turbulent force, we have studied. Okay, if we, there are two types of flow, right? One is laminar flow, another one is turbulent flow. We will discuss that in detail also about 2-3 lectures later. But you must remember when we studied about the various types of when we studied about classification of flows, the lecture that was on classification of flows, here I talked about laminar and turbulent flow, right? I discussed in that class that it depends on Reynolds number. However, I didn't went into detail in that class. I told you then that we will study about it later. So the time is coming now. We will study about Reynolds number, the very important constant, the very important number in the study of fluid mechanics. We will study about Reynolds number. So the Reynolds number tell us whether my flow is turbulent or laminar. Okay, we will study it in detail, but yeah, if the flow is turbulent, then the turbulent forces will come into picture, and these forces are also very important, and this makes the analysis very complex. I will not go into detail right now, but yeah, so this is also need to be taken into account. Turbulent force. What is another force? Another force is compressibility. Compressibility force, or force due to compressibility, you can say. It is denoted by Fc. Now my fluid can be compressible or it can be incompressible, right? So if my fluid is compressible, the behavior of fluid is very different. However, that is out from the domain of our syllabus. We will not study about compressible flow, that is not in our syllabus. But yeah, if my fluid is compressible, its study is quite complex than the incompressible fluid. However, what we are going to study only incompressible fluids. We will not study about compressible fluids. Fine. But yeah, we need to take into account, we need to mention everywhere if we are making this study, if we are doing any analysis, we need to mention that considering, or if it's given, if it's not given, then we will mention here that considering the incompressible flow. You need to mention that if you are doing the analysis based on what we are going to study. Okay, so these are the various forces. Okay, so I can say what is the net force that is acting on a fluid. It will be equal to F is equal to Fg, force due to gravity, plus Fp, force due to pressure, plus Fv, viscous force, plus Ft, turbulent force, plus Fc, compressibility force, right? These are the total forces acting on a fluid at any instant, at any location. Okay, now there may be some forces coming into picture, or maybe some forces not coming into picture. Okay, or we can certainly neglect some forces to make this study easier. It is also possible, which we are going to do. You will see that sometimes to make the analysis easier, we quite assume some things, that let's say compressible, it's not compressible, turbulent forces are not there, viscous forces are not there. So we do such things to make the analysis easier. Okay, so let's see. So first of all, this is my master equation. Okay, This is my master equation, that is the all the forces, combination of all the forces. So first of all, we have already studied that we are going to ignore the compressibility forces. So let's say I say that F is equal to Fg plus Fp plus Fv plus Ft. Okay, my first assumption is Fc is equal to 0. Okay, or I can say incompressible flow. Incompressible flow. If this is my assumption, then the analysis, this analysis is called, the analysis of these forces is called Reynolds analysis. Reynolds analysis. Okay, here in Reynolds analysis we ignore the compressibility force, the forces that are coming due to compressibility, we ignore that force. Okay, so now if I ignore the turbulent force also, if I consider that my flow is laminar, okay, if my flow is laminar, then, or we can say if my Reynolds number is small, then F will be equal to Fg plus Fp plus Fv. Fine, here Ft comma Fc both are equal to 0. Okay, that is laminar flow. Laminar flow, it's incompressible also, obviously it is also a laminar flow. This analysis is called, the analysis with these assumption is called Navier-Stokes analysis. Navier-Stokes analysis. Okay, this is Navier-Stokes analysis. It is generally based on conservation of momentum. Just keep it in mind, it has already been asked in GATE examination. Just cram this, I will say, conservation of momentum. This analysis is based, we are not going to do the Navier-Stokes analysis, it's quite complex, it's out of our domain of syllabus, but yeah, just keep that in mind, that Navier-Stokes analysis is based on conservation of momentum. Now what if I say that my fluid is ideal, its viscosity is also not there, then force will be equal to Fg plus Fp, right? Here Fv comma Ft comma Fc is equal to 0, right? This is ideal flow, yeah, ideal fluid. For ideal fluid, viscosity is 0, viscous forces don't come into picture in ideal fluid. Okay, so this analysis is called Euler analysis. Euler analysis. Okay, here the fluid is ideal. So basically when we are going to study, so obviously the lesser the forces you take into account, simpler is the analysis. Fine. So if I do not take into account the viscous force, turbulent force, Fc, obviously you can see that Euler analysis must be very simple, right? When you are not taking into account the various forces, that is viscous force, turbulent force and compressibility force, then your analysis will be simpler. So for how we are going to study, how our study is going to flow, first of all we will study about Euler equation, then we will came into quite just a modified part of Euler equation, that is Bernoulli's equation. I am telling you what we are going to study further. Okay, then we are going to study Bernoulli's equation, then we are going to study about application of Bernoulli's equation. Bernoulli's equation is quite a big, Euler equation just an introduction. Okay, it's not such a big part, but yeah, Bernoulli's equation, first of all we will study about Bernoulli's equation, then we will see what are the application where the Bernoulli's equation is applied. Okay, it's a very important equation in our study of fluid mechanics. This is a very important concept. So then we will study about Bernoulli's equation. Then what will came into account here in both equation, these forces that come into pictures are gravity and pressure forces. Okay, then next we will take into account viscous forces also. Okay, then we will study about viscous forces. This will be our next study. After Bernoulli's equation we will study how to calculate the viscous forces, how it affects our fluid motion, or right, we will see it. Then we will study about turbulent forces. turbulent flow basically. Okay, that how the turbulent flow is studied. Okay, yeah, compressible flow we are not going to study, that is out of our domain, that we are not going to study. So this is how we will move from simpler to complex. First of all, Euler analysis, then we will study about Euler equation and Bernoulli's equation, then we will move to viscous forces, then to turbulent flow. Okay, compressibility analysis is not in our syllabus. Fine. So in next class we will study about Euler equation. Well, if you have any doubts or any comments, put it in comment section. We'll meet you in next class. Bye bye.